Did you know that the strongest magnet in the world isn't man-made? It's actually a star called a magnetar, which is a type of neutron star. Now that's some real star power. Welcome to our magnetic journey where we'll unravel the mysteries of these fascinating objects we call magnets. You see, magnets are not just those colorful fridge decorations that hold up your latest art masterpiece. There's so much more, and today we're going to explore just how much more they truly are. We'll discover what a magnet really is, dive into the fascinating process of how they're made, and explore their handy uses in our daily lives. Plus, we'll get to know the different types of magnets that exist. From the ones in your headphones to the ones in MRI machines, magnets are everywhere. Now, are you ready to dive into the world of magnets? Buckle up because this is going to be a magnetic journey. Imagine you're a superhero with the power to attract certain things towards you. Well, that's kind of what a magnet does. Now you might be wondering, what exactly is a magnet? Let's dive into that. In the simplest terms, a magnet is something that pulls or pushes other things. These other things are usually metals like iron, nickel, or cobalt. Have you ever played with two magnets? If you have, you might have noticed that sometimes they pull towards each other and sometimes they push away. This is because every magnet has two ends or poles. These are called the North Pole and the South Pole. When you bring two magnets close, if the North Pole of one magnet meets the South Pole of the other, they attract each other, they pull towards each other. But if the same poles meet, say North Pole to North Pole or South Pole to South Pole, they repel each other, they push away. Kind of like when you and your best friend see your favorite ice cream, you both rush towards it, you're attracted to it. But when it's broccoli for dinner, oh boy, you both want to be as far away from it as possible, you repel it. That's how magnets behave. But why does a magnet behave like this? Well, it's all because of tiny particles called electrons. In most objects, these electrons move in random directions. But in a magnet, most of them move in the same direction. This creates a magnetic force. This force is what pulls some objects towards the magnet and pushes others away. So, imagine if you were like a magnet with your own north and south poles. You could pull your favorite toy towards you or push your homework away. Wouldn't that be fun? So, just like a superhero, a magnet has the power to pull some things towards it and push others away. How cool is that? Now, have you ever wondered how a magnet is made? It's not as complicated as you might think. You see, our journey begins with certain special types of metals. Not all metals can become magnets, oh no. It's only the select few, like iron, nickel, and cobalt, that have the potential to be transformed into these fantastic magnetic marvels. So, how do we turn these metals into magnets? Well, sit tight because here comes the fun part. The process is all about aligning the atoms. Picture it like a tiny, tiny army of atoms all marching in the same direction. When these atoms are scattered haphazardly, the metal isn't magnetic. But when we get them all lined up, just so, the metal becomes a magnet. But how do we line them up, you might ask? Great question. It all starts with heat. We take our metal and heat it to incredibly high temperatures. This heating makes the atoms inside the metal all jumbled and excited. They start moving around, ready for action. Next, while the metal is still hot and the atoms are all aflutter, we apply a magnetic field. This is like giving our little atom soldiers a direction to march in. The magnetic field aligns the atoms in the same direction, and with a quick cooling, we lock them into place. So, does this mean any piece of iron, nickel, or cobalt can be a magnet? Well, theoretically yes, but it depends on how well the atoms are aligned and how strong the magnetic field we apply is. The stronger the field and the better the alignment, the stronger the magnet. And voila, that's how a magnet is made. It's quite an electrifying process, isn't it? This process, my friends, is called magnetization. And now you're officially a magnet-making mastermind. From a piece of metal to a magnet, it's a journey of heat, alignment, and a whole lot of atomic marching. So the next time you're playing with a magnet, remember it's not just a toy, it's a scientific marvel. Did you know that magnets are all around us? They're in everything from your refrigerator door to your favorite toys. Now let's dive into the fascinating world of magnets and explore how they're used in our everyday life. Magnets, those magical forces of nature, aren't just for sticking things to your fridge. They have a whole range of uses, some of which might surprise you. For example, did you ever wonder why your refrigerator door stays shut? Well, it's thanks to the power of magnets. They're used to keep the door closed so your food stays fresh and cool. Let's take another example. Ever heard of maglev trains? They're super fast trains that float above the tracks. How? You guessed it. Magnets. The train is lifted off the ground by a magnetic field, creating a smooth and frictionless ride. Now let's talk about the different types of magnets. There are many types, but we'll focus on three main ones. bar magnets, horseshoe magnets, and electromagnets. First, we have bar magnets. These are the magnets you're probably most familiar with. They're called bar magnets because, well, they're shaped like a bar. They have two poles, one at each end. One end is the North Pole and the other is the South Pole. Opposite poles attract each other while same poles repel. Next up, we have horseshoe magnets. Guess why they're called that? Because they're shaped like a horseshoe. These magnets are super strong because both poles are close together. This means the magnetic field between them is very strong, making them perfect for lifting heavy objects. Last but certainly not least, we have electromagnets. These aren't like your regular magnets. They're created when electricity flows through a wire. The cool thing about electromagnets is that you can turn them on and off. When the electricity is switched on, the electromagnet works. When it's off, it stops. This type of magnet is used in a lot of places, like in electric motors or even in junkyards to lift heavy metal objects. So, there you have it. From keeping your fridge door closed to powering super fast trains, and from the simple bar magnet in your science kit to the powerful electromagnet in a junkyard, magnets have an amazing range of uses. They come in all shapes and sizes, each with its own unique properties and uses. So whether it's holding up your latest artwork on the fridge or powering a toy train, magnets sure do a lot. Alright, it's time to put on your thinking caps. Let's see how much you've learned about magnets. Question 1. Can you name the two ends of a magnet? That's right, they are called the North Pole and the South Pole. And just like best friends, opposite poles attract each other. Question 2. How are magnets made? Yes, indeed. They are made by exposing certain materials to a magnetic field. It's like giving them a superpower. Moving on to question 3. Can you remember the different types of magnets we talked about? Permanent magnets, temporary magnets, and electromagnets, you got it. Each one is special in its own way. Question 4. What are some uses of magnets? Excellent. They help us in so many ways, from sticking notes on our fridge to powering electric motors. Without magnets, our world would be a much different place. And now for the final question, question 5. Can you name something in your house that uses a magnet? That's it. There are so many things, from the door of your refrigerator to your favorite toy. Magnets are everywhere. Now let's check your answers. If you got all the questions right, give yourself a big pat on the back. If you missed a few, don't worry. It's all about learning and having fun. Remember, just like a magnet, you can attract knowledge and keep learning. And that's a wrap on our magnetic quiz.